Hello, I'm Neocrius, and in this video I'm going to talk a bit about the interaction of light with different materials, and I'll show you how I shade smooth objects in digital ink. I'll start by drawing three spheres made of different materials, each lit by a single light source. Let's imagine the first one is made of plaster, the second one of plastic, and the third one of metal. While light can penetrate the surface of non-metallic materials, leading to refraction and other phenomena, metals in general either absorb a particular wavelength or reflect it fully. That's what gives metallic objects a distinct look. These diagrams illustrate that principle. Since plaster is a matte, non-metallic material, it behaves according to Lambert's cosine law. For us artists, this means that the brightest spot always points exactly towards the light, no matter from where we look. The second material is also non-metallic, but slightly darker and polished to a high gloss. Most of the light in this case will still be scattered according to Lambert's law, but there's also a small portion which will be reflected in a mirror-like fashion. This mirror reflection is faint, so we'll only really see the light source in it, which will create a bright spot on the surface called a specular highlight. It won't be facing the light, but rather be closer to the center of the sphere, where the surface normal bisects the angle between the light source and the eye. The third sphere is metallic, which means it will reflect light like a mirror. Surface roughness may cause the bounced rays to scatter to some extent, leading to a diffuse reflection. Nevertheless, it will never look like either of the first two materials. It doesn't have a terminator or lit and unlit hemispheres. Just a blurry reflection of a sky and a ground I've invented, with the brightest spot being the reflection of the sun. This next diagram shows that as the surface of the first two spheres turns towards the terminator, the cross-section of each segment facing the light decreases. This is the reason for a fall-off of luminosity near the edge of the lit hemispheres. I've chosen to depict the unlit hemispheres illuminated by light reflected from the environment, otherwise they'd be totally black. Whether to draw such reflected light depends on the proximity and brightness of other objects in the scene, which can create so-called ambient occlusion. That's a topic for another video, perhaps. Note that while I was shading the spheres, I didn't extend the hatching to the very edge. This is to suggest another optical phenomenon called the Fresnel effect, where grazing reflections near the outlines of rounded objects are stronger. Alright. Now it's time to show you my technique for creating smooth gradients. With ink and hatching, you only get a handful of tones you can create. Whenever I need to blend these tones together is one of the few instances where I use layers. I draw each successive hatching direction into a new layer, then erase the ends of the lines using a zigzag motion to create dashes and dots. Here's how it looks on its own. It's possible to achieve this effect without layers, but it's much harder. You have to interrupt each hatching stroke at one or both ends, which slows down the process and is difficult to judge correctly. Whether you use layers and erase, or draw the dots and dashes right away, it will help blend the new layer of hatching into the previous one. Armed with some rudimentary physics knowledge and a technique for smooth gradients, I'm now going to draw two cylinders. One will be non-metallic and the other metallic. Here you can once again see the erasing technique, which is very quick and controllable. The second cylinder will have an invented reflection of some non-existent environment. And there you have it, my technique for drawing smooth objects from imagination. Thank you for watching and see you in my next video.